Okay, let's officially start with today's webinar with the topic Complete Guide to Map Power Lines with 3D Survey. Happy to be today here with you. So my name is Marko and welcome to today's webinar. It will be another interesting topic. We will push the photogrammetry even harder, try to extract power line cables from the images. Usually those kind of projects in past surveyors or mapping companies have been doing with laser scanners and airborne lidar. But we know the photogrammetry is powerful enough also to extract those kind of data and get even nicer, more realistic results out of it. And today I would like to show you how to correctly do it, everything. So if I continue with my short presentation, some of you probably already know me. My name is Marko. I'm part of a 3D survey team. I'm a land surveyor with a bit more than 11 years of experience. I did a traditional surveying with total station, GNSS, measure all kind of surveying projects. But no, for more than 10 years, I'm in photogrammetry business. So we are developing 3D survey software, which is a kind of best software for 3D modeling, point cloud calculation, drawing CAD lines, volume calculation, measuring, and bring your results to finished results, which you can share with your customers. I work on more than 1,000 plus photogrammetry projects already now. I'm also product manager at 3D Survey and a drone trained pilot operator. Today's project, we will have a look about project description. As you already heard in the topic, we will try to explain you how the most effective map power lines in greater distances and how to process them correctly and what can you at the end extract out from this data. We will see quickly equipment description which have been used in this project. Then we will spend a bit more time for instructions for data acquisition and camera settings, and of course basic workflow with results will be also presented. Before we continue with all this, we have a short poll for you. 4 questions are today available, and please answer those questions. So I will launch my first question, and this is it. How did you find out about 3D survey? Okay. First answers are already coming. 40% of you already voted. 50%. Let's wait a couple of seconds more. Okay, we see. Let's close the poll. And the results are 23% through friends recommendation, 34% through a seller of surveying equipment, the same percentage through the website, and 9% via Facebook and Instagram. Okay, of course, I can share also those results with you. And let's set another question. Would you recommend 3D survey to your friends? Okay. 65% already answer it. Let's close the pool and share the results with you. So 94% yes, 6% no. Hopefully after today, those 6% will be change their minds. Let's see. And go with our third question. What do you think about 3D survey workflow? So is it easy to use? The software is complicated, or I'm still not using 3D survey software? So in this question, we mean the basic workflow from images to orthophoto, and then maybe some functionalities and so on. Okay, 65% already answered, 70% Okay, let's close this one and share the results with you. So 50%, a bit more than 50% think that it's easy to use. 40% tells that it's complicated, and 34% I'm still not using the software. Okay, just one more question, the last one. Are you already working with the LiDAR data for your projects? So this question is directly connected with today's webinar. LiDAR data already more than 5 or 10 years available, sometimes free of charge from some kind of web portals. For example, for our country in Slovenia, you can free download them from a web page and use them in your today's work. Okay, let's close the pool. Most of you already answered it, and we see 28% yes, 60% no, and 13% of you selected what is LiDAR. Just quick explanation, LiDAR is actually laser scanner which produce point clouds similar to photogrammetry, but by default it does not have color. You can put the LiDAR on airborne, even on drone, and map the entire area with it. So the same project we did today with the photogrammetry, you could also do with the LiDAR, but of course equipment costs 10 times more and so on. Okay, thank you for your answers, and let's get back to our presentation. And the first point is project description. So object size, we mapped approximately 500 meters of power lines. There were 2 power poles and 4 cables in between. The highest power pole was 40-meter height. This is kind of tricky project for photogrammetry because we have a lot of detail on the terrain level, and then 30-meter nothings, and then just small details with cables and so on. So it's kind of pretty tricky for the processing, but if you do it correctly, you can manage to do it easily. For mapping, we used linear flight. So the drone just fly one way, turn back the other way, and one way back. So altogether there were 3 lines. What was super important here, we need to fly high enough. So we did a fly on 100 meters, or actually on 80 meters. And then just for safety, I did also a second flight on 100 meters because we need to have good overlap between images. And so our suggestion is fly enough high. And the second option is what you need to take in approach. We suggest you to turn the camera gimbal a bit in front. And I did with a 60-degree camera gimbal and get really good results out of it. This helps you to increase the overlap between images, because if the camera is pointing in front, we get more area in the same image, longer cable size, it's on the image, and it's easily to reconstruct out later also the points. Okay, so our suggestion, as you will see later, is fly, if you have a power poles with 40 meters, fly on 100 meters. If you have higher, fly on 120, 140 meters, and set the camera a bit front. So I use the 60% gimbal, and gives me great results. So 90 degrees it's fully down, 0 degrees is horizontal view, and 60 degrees is a bit in front. You will see later also in the software. We don't use any ground control points for this project because we have an RTK drone, and the accuracy up to 5 centimeters, it's more than good enough in an absolute way. In realistic, if we would measure distances between cables, we have in the centimeters. Some kind of specifics. Currently, I had an open area, no trees were there. If I would have some vegetations, I would do it the same way. And if I would have a longer distance, so let's say 10 kilometers, I would just repeat the process the same way like here. Usually you can map with a one battery 1 kilometer of a power line, or maybe if you are really advanced, you can do it 2 kilometers, then you go further, do another measurements and so on. Okay, then equipment, okay, pilot on left side, and we use the Phantom 4 RTK. In this case, we didn't need to use ground control points. If I would need to place ground control points, this would take me an additional time. In my case, I use less than 10 minutes to map 500 meters of power line. But in case I don't have an RTK drone, I would place, let's say, 6 ground control points for this area. And of course, 3Dsurvey software for processing all the data. Then instructions for data acquisition. We can nicely see on the image those 3 lines, how the drone was flying. Under it, we see immediately also the point cloud, which was already calculated. Again, the camera was pointing a bit in front. You will get this explanation also later on. Then the camera settings, usually we explain to our customers, do the first 10 projects on auto, and then after this, use shutter priority. And we are already in September. I think we have a nice sunny weather. I think I use 1 per 1,200 of a second shutter speed. If I would use 1,000, as explained here, would be also good enough. So those are some general guidelines which usually works fine. But it always depends if you have grass, rock, or what kind of terrain you have under it. Okay, and then don't forget camera angle 60 degrees. Okay, then mapping method I already explained. So this was a linear flight. Later in the software, we will show you also image preview that you can have a good feeling how we trigger the camera. We will see also the quick processing workflow, result presentation, and of course, general presentation video. Okay, we create also a short video on a field, how we map everything, that you can have even better idea. Please don't forget, if you have any questions during the webinar, please feel free to write them in the question box. It's on your right side of the webinar platform, and I will try to answer those questions at the end of the webinar. Okay, feel free to write them during the webinar if you get some questions, so that we can answer them at the end. Okay. Cool. And let's share with you video from the field, and then we will directly go into the processing and explain you everything how it goes.
Hi everyone, Marko here from 3Dsurvey. Today our mission is to map approximately 1 kilometer of this power line. It's kind of pretty high poles, approximately 30 meters or something like that. And in next part we will give you some tips and tricks how to plan your mission to achieve accurate and sophisticated results. For this mission we will use Phantom 4 RTK. We will plan a mission in a DJI application. As you probably already know, we have also our own 3Dsurvey pilot mission app, but unfortunately on the integrated screen of RTK we will use the DJI application. We are not going to use ground control points for this project because accuracy with the integrated RTK GPS is more than enough for this kind of project. We need actually more or less relative distances between cables and terrain, and accuracy is more than enough without ground control points if you use such a RTK drone. What's interesting here, we need to fly enough high not to hit some kind of power lines. Before, we always advise you to inspect the terrain a bit, so to see if the terrain is going up and down and so. And I would suggest you to fly for that kind of objects on 80-meter height with camera not turned fully down, so nadir images perpendicular to terrain, so the flying height 80 to 100 meters. If you have even higher poles, then go even higher. What's super important, and we will talk a bit more later when we plan a mission, is you need to get really high overlap between images, because when you plan a mission in such a mission planning app, you always calculate the overlap on a terrain level, and if you need to get a point cloud from the cable to later extract the data in 3D survey, you need to have also minimum 60% of the overlap on the cable height. So it means we will push the overlap mainly to maximum, let's say 90% or something like that, and in this case we will achieve really good results. So this project we mainly do to extract the cables and how high are they above the terrain, or how far are they from the vegetation, if they need to cut the vegetation or something like that. So this is a pretty useful tool to monitor it. I should say you can usually do this 10 kilometers per day or something like that with this equipment and 3D survey. For this purpose we will actually capture 1 kilometer with 2 big power lines and then power poles, and in addition there is a bit more power lines beside our area of interest. Okay, this would be everything from the intro. Let's go on, turn on the drone, start mission planning, and that's it. Okay, we already turned on the drone and we will select a plan mission. For these purposes we will use linear flight mission tool. Here we can see our 2 power lines, and I will just select a bit bigger area in between. So this is my first point, here is my second point. This is actually 500, almost 500 meters, which is good enough for these purposes. Side distance I'll put to 50 meters. I don't need a lot of area beside my main line. And okay, let's generate a flight route, and we get 3 lines for flight, and this is also minimum. See, we always advise you to have at least 3 lines to capture images, because this will give you accurate results at the end. 2 are also okay, but if you like to get the highest accuracy, 3 are mandatory. Okay, I will set here 80-meter flying height, because I need to have high resolution also on power line cables. The dimension of these power lines, probably they are wide 2 or 3 centimeters, and we need to see them on image accurately. Okay, so the flying height is the first one. I changed to 80. Then everything else is okay here. I will set camera settings parameters here. We have a sunny weather. I will use shutter priority, and for this kind of weather, let's say 1/800 will probably be a good choice. We have also a lot of webinars which are explaining how to set your camera perfectly and so on. So check out this one. And always when you map with DJI RTK drone, use distortion correction on. Okay, this will gives you more accurate data, a nicer orthophoto, faster calculation. So in this case the drone is already calculating the first camera distortion based on parameters, and then later in a 3D survey software we do it again, but it's just more effective, everything. Okay, let's save this one and go to advanced settings. Here we have horizontal overlap. Let's put this one to 90, and vertical overlap also 90. Okay, when I put the horizontal overlap to 90, I get actually 5 lines. So maybe I will go back. It's not possible to go back. Then I will go advanced settings and smaller the overlap to 87%, where I still have just 3 lines. If I will have 5 lines, I need more battery, the flying time is longer, you can map shorter distances with a single battery. So in my case, on 80 meters, horizontal overlap 87%, vertical 90%, this is more there. Perfect. Save. I think everything is now preset. Mission, so let's say flight 1, done, confirm, and we are more or less ready for takeoff. I need to click on invoke. Once again, need to wait for the GPS and everything else. We are ready to go with the RTK. The home point is recorded. Let's click on invoke, start, and the drone should start in few seconds. Let's slide to execute.
Start operation.
Okay.
Home point recorded.
Let's see. Okay, we are going up. The mission takes approximately 8 minutes or something like that. Currently we are on 80-meter height. During the flying we can always see on the screen where the drone is, where the camera is pointing.
Please pay attention to flight safety.
So all the telemetry data is on the screen. We turn down the camera. If I click on a camera view, we can immediately see our area of interest. We can also see the cables are nicely visible on it, and we are mapping. Okay, so we finished with mapping. It was a bit more than 5 minutes, so we are already over our home point on 80-meter height, and now we will start ascending. Everything happens automatically. I can also turn on the gimbal during the flight on to see where is pointing my drone. If I would need some additional images from the power pole, I could trigger additional cameras, but in this case my main goal is to extract cables from power poles and so on in 3D, so I need a 3D vector line, and of course terrain point after the power pole, the height of the power point, and so on. So for these purposes the fully automatic flight was more than enough. We see the drone is landing automatically, and after less than 10 minutes we finish actually with our mission, and this is more or less everything from the field. Let's go back into office, start with the processing, and show you some real results.
Okay, we are back in office, and here we can see already our area which we map with the drone. 157 images. On the right side you can see the number. All of the images are selected. Let's see the images in telemetry view. If I toggle text off, we see how the drone was flying. Here you can also see that the camera was turned 60 degrees front, so this helps us to get better point cloud from the cable, because longer distance from the cable is visible on a single image. With this trick we actually increase additional overlap between images. Okay, and we see the drone was flying here in front, the camera is pointing a bit forward, once again 60 degrees, and when it flies back it looks the other way, and then again back. This is still not too much, and all images, so from the first line, and when it flies back, second line, the camera is pointing to other direction, but not too much, and all the images are able to successfully match them together. Okay, we are not going to spend too much time with the basic workflow, how to process now this data. I already did this, that we don't need to wait too long. You have a number of other webinars where this explanation is available. I will just repeat quickly again. After I was importing images here inside, we have 3 steps: bundle, adjustment, orientation, reconstruction, and after the reconstruction we get the dense point cloud. We will see it in a few minutes. Before that, I would like to just quickly go through the images that you get a good feeling how the camera is pointing. So here is our first pole, and then we have cables here. If I zoom in, you see the cable is still visible. It's maybe on 1 or 2 pixels visible. This is more than enough for our software. 3Dsurvey actually generates the best point cloud on the market with the highest detail, and this is great to get out the details also from the cables. This kind of project, it's kind of pretty tricky, so you need to know what you are doing, because it's hard to get cables from the images, because there is a lot of terrain on a field, and then you have 40 meters higher some detail you would like to get also, and that's why listen to these instructions. Fly high enough, so 80 or even 100 meters above the terrain if the poles are 30 or 40 meters. If those are bigger, you will need to fly to 120, 140 meters. And not to forget, turn the camera a bit in front. I did with a 60% gimbal angle, and I was successful. So fully downs mean 90 degrees, horizontal view is 0 degrees, 60 degrees it's a bit in front, okay, but it's nicely written in application for mission planning. Okay, so let's go a bit for next image. This is our second pole, also nicely visible. All the connections, cables, pole height. Let's go back to images. Here the drone was turning around. The complete distance here was approximately 500 or 600 meters, and then we fly back like so. What's here tricky? So as you can see, the first pole has the cables just on one side. After I process the result, I get the results. I was looking where the other cables are, and actually cables from the second poles are going back then to the left side. So first time I was shocked. Okay, where are the cables? But then I figure out with the help of the images that this is fully normal. Okay, now I probably have a good feeling. Then after the bundle adjustment, we get so-called sparse point cloud. It looks like so. So the cameras are visible, a lot of terrain is there, and a bit of details from the poles are already visible. And this is just a sparse point cloud. Okay, then we did orientation just based on telemetry. We didn't use ground control points for this project because we have a RTK drone. 5 centimeter absolute accuracy is more than good enough for this kind of projects, so we don't need any ground control points. And in case I would have here 10 kilometers of a power line, this will just speed up the field workflow if I don't need to use ground control points. So this is the best practice, high efficient work. Try to use a RTK drone for that kind of project. If I would have here Mavic 2 Pro or something like that, or Phantom 4 Pro without RTK, I would need to place, let's say, 6 ground control points. But nevertheless, much faster with the RTK drone. It took me less than 10 minutes to get those data. And then after the reconstruction, we get out point cloud like this, 33 million of points. This is the point cloud calculated on high level. We have also extreme level, which doubles the number of points, but of course takes double the time. For this 152 images, it took me 1.5 hours to generate this point cloud, and it looks like that. So we can see the cables are clearly visible here. We have also our first power line pole with just the right cables. There are no left cables. We saw them also in images. There are no cables. And then the second pole, which was our area of interest, also nicely visible here. If I would fly even higher, I would probably get a bit more details also from the poles, but in my case I don't actually need it. Other option would be that I will do additional circle flight with the camera pointing in the center of the pole for every pole, and this will give me even better 3D point cloud from the poles. But of course this takes additional time on a field, and if you don't need it, why should you do it? Additionally, there were a bit smaller pole lines also in addition, left and right, and you see we get them also, most of them. I don't actually need them. That's why my next thing I'm going to do here is I will use selection tool to select my area of interest, like so. And I will click delete other, that I will focus just on my area of interest. Okay, I still need to clear out a bit more. Maybe I will use bounding box here. Right mouse click on the corner to rotate it. Right mouse click to rotate it. Right mouse click to move the plane. Okay, a bit more. Turn it off, and I will additionally delete this part. So with the bounding box, I'm just hiding the data. When I click reset view, everything is back. Okay, I cleared the main line. Let's clear also points which I don't need from this side. I can also just turn it like so, and that's it. Selection with left mouse click, finish my selection with right mouse click, and then delete on keyboard. Okay, here I have my two main power poles. What I need to get out now is the height from specific power pole, and of course the position of cables, and I will focus mainly on cables between those two power poles. So the easiest way is to go back to CAD. I'll create a new layer, power pole. I'll just set kind of a red number, make the layer active, set the new point, and okay, and pick my point here actually. Okay, this is kind of the highest point, and also the point for communication cable between the poles. So let's go to second one. Okay, clearly see. You can also use the point render size to increase the point render size. The points are not nicely visible, but in my case it's already okay. Let's go back to CAD tab and generate my second point. So from the point cloud I can see this is my second point here. So 363.69. Okay, we see this one is much higher than this one, and those 2 points define me now the height of the power poles. Now I will go and create my second, let's say cable, make the layer active. I'll put the cable, let's say a blue color, and I could immediately draw lines, or I could first create points and then connect the points with the lines, but let's go with a draw line tool. I would like to have point on vertex. This will create me additionally points on my lines where the break line is. Name okay, height okay, and let's start drawing. First I will snap to my point and then to the point cloud point. Okay, and in this way I will just go and connect. This is, I think, the communication. Okay, here I don't need additional point. I just turn on the point on vertex off and snap on point and finish my selection. Okay, nice. Here I generate 1.2 much, so I will go and select the number 3 and delete it with the keyboard. And as you already see, I generate my first cable. Now I need to repeat the process 3 more times for 3 other cables, and then we have vectorized power line cables from our model. Let's speed up a bit. Okay, those were actually my main power lines. Then I can see here the points maybe are no, I have too many points with too many heights or something like that. Let's use the multiple selection tool just to select the first point and then select similar, and I will just turn them off. So for now I don't need them, and in this case I just hide the text and so on. Okay, we successfully extract the cables from our power pole. The next thing I would like to extract is the position of the power pole. For this purpose I will use, because I have a lot of vegetation right around my power pole here. Not sure if the second one has the same situation. No, here it's nicely visible, but I would like to show you just the second option, how to extract also corners from the power poles. And it's actually, let's go to the point cloud. We will extract this with the help of the digital terrain model and the orthophoto. But before that, I will turn off cat. I need to classify my point cloud to get just terrain points. Okay, need to click one terrain point. It's more than enough. Let's go to the next step. So this is a standard 3D survey classification, super easy, fast and efficient. I will just click delete other, and most of the terrain is immediately there. I will also generate my mesh, regular grid mesh, 1 meter grid cell size, or only inner for this case, and 1 cell. And this is my digital elevation model already. There is some corn inside, but doesn't care in this project. Okay, and let's do the orthophoto calculation just really quickly. Okay, here is my ortho. Because I have a number of side images from the power poles, I will just do the recalculation for this area, select my area. Let's use the best possible image, probably this one. It's already good, so confirm it, recalculate orthophoto. Okay, the power pole is nicely visible. It's not fully vertical because the camera was not pointing perpendicular to terrain, so but I don't need it actually. I need here the position from my power pole. Let's see the second one. Okay, here is already nicely visible, even better here. Okay, I will confirm with this one, recalculate orthophoto. And I have my position where the pole is going inside in terrain, exactly visible on ortho. Okay, cool. And now I can go back. I can drape orthophoto, calculate, get the texture on my digital terrain model. And if I go now to CAD, let's turn also points before down, clear, CAD. And now I can actually draw the power pole with the help of digital terrain model and orthophoto. Let's make the active layer, start drawing, and now I will just snap on the triangles from the digital terrain model. Image help me to define the accurate 2D position. Digital terrain model gives me the position of height, and in this case I can define my position like so. Okay, let's do it the same thing for the second one. So here's one corner, another corner, third corner, fourth corner, and snap on endpoint. Okay, cool. Additionally, let's connect those characteristic lines together, snapping on endpoint like that. Okay, the first one is done. Okay, that's it. So we have some kind of rough 3D models from the poles. We have cable positions. I could do some additionally drawings from power poles, but for my purpose this is more than enough. Let's go back. What we need in addition here is some terrain points. I will generate those one with the help of our generate CAD points generator. Let me just create a new layer. Let's say terrain, heights, and leave the color standard. This is all good. So first selection, like so. And now generate cat points, snap on lowest. I will put 10 meters, not to have too many points, from current selection. And points are here. Okay, we extract here the cables out from the point cloud, we extract the power poles, we get some terrain points. Let's additionally measure how far the lowest cable is from the terrain. I will use for this measuring option nearest snapper. Let's see, probably here is the lowest point, and then I will use the top-down function. So again, rotate a bit, and we can see 30.57 meters from the terrain. So we could measure this distance anywhere we'd like to. If there is some vegetation, we can measure how far the vegetation is away from the cables, if they need to cut the vegetation or something like that. If the road is running here, you can measure it, how far the pole is, how far the cable is. So all the data you would like to have are available in your model. Let's see just the digitized model. We did it. And yeah, this is more or less everything. Hopefully I give you a good idea how to do it, what can you get out from this data, and of course, if there's anything else, questions are always welcome. Okay, great. So this was most from our today's webinar. Hopefully it was interesting for you. Hopefully you find some good ideas how to work with this kind of projects, or maybe get a good idea how to place those techniques to other applications based on your daily projects and everything like that. Now it's a good time for questions, if there are some, that we can answer them directly. So feel free to write your questions in the question box, that I can answer my question. We are right on time, so everything is fine. Let's wait a couple of more minutes if there's some question comes. Otherwise, this was more or less everything from our today's webinar, a bit different one in comparison to the previous one. And I would just like to say thank you for watching for today. Don't forget to register on another webinar, which will probably come in the next 14 days or a bit later. And thank you for watching.